The dictionary is not literature. Martin H. Fischer Chapter 1 Chemical Reactions and Equations. Consider the following situations of daily life and think about what happens when milk is left at room temperature during summers. An iron tawa/pan/nail is left exposed to a humid atmosphere. Grapes get fermented, food is cooked, food gets digested in our body, and we respire. In all the above situations, the nature and identity of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1.1 Caution. This activity needs the teacher's assistance. It would be better if students wore suitable eyeglasses. Clean a magnesium ribbon about 3 to 4 centimeters long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash formed in a watch glass as shown in Figure 1.1. Burn the magnesium ribbon, keeping it as far away as possible from your eyes. What do you observe? Figure 1.1 Burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass 2024-25. You must have observed that the magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Activity 1.2 Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? Activity 1.3 Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulphuric acid to this. Figure 1.2. Caution. Handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? From the above 3 activities, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place: change in state, change in color, evolution of a gas, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study the various types of chemical reactions and their symbolic representation in this chapter. 1.1 Chemical equations. Activity 1.1 can be described as, when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above.
The best way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium oxygen magnesium oxide, reactants, 1.1, product. The substances that undergo chemical change in the reaction, 1.1, magnesium and oxygen, are the reactants. The new substance is magnesium oxide, formed during the reaction, as a product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side, LHS, with a plus sign between them. Similarly, products are written on the right-hand side, RHS, with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Science.
1.1 Writing a chemical equation. Is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium oxygen and magnesium oxide, the above word equation can be written as Mg O2 MgO 1.2. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. 1.1.2 Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same, before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc sulphuric acid zinc sulfate hydrogen. The above word equation may be represented by the following chemical equation: ZnH2SO4 ZnSO4H2. 1.3. Let us examine the number of atoms of different elements on both sides of the arrow. Element ZnHSO number of atoms in reactants, LHS, 1-2 number of atoms in products, RHS, 1-2-1-4-1-4 as the number of atoms of each element is the same on both sides of the arrow. Equation 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation: Fe-H2O Fe3O4H2 1.4. Chemical reactions and equations 3:20-24 to 25. Step I. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Fe-H2O Fe3O4H2 1.5. Step 2. List the number of atoms of different elements present in the unbalanced equation. 1.5. Element Fe-HO number of atoms in reactants, LHS, 1 number of atoms in products, RHS, 3-2-1-2-4. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms of oxygen in reactants and products, I, initial, 2, to balance 1, in H2O, 4, in Fe3O4, 1/4 to equalize the number of atoms. It must be remembered that cannot alter the formulae of the compounds or elements involved in the reactions. For example, To balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O4. Now the partly balanced equation becomes Fe4H2O Fe3O4H2, 1.6, partly balanced equation. Step 4. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atoms, make the number of molecules of hydrogen as 4 on the RHS. Atoms of hydrogen in reactants and products, I, initial, 2, to balance 8, in 4H2O, 8 the equation would be Fe4H2O Fe3O4 4H22, in H2, 2 by 4, 1.7, partly balanced equation. V. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is, iron. Atoms of iron in reactants in products, I, initial, 2, to balance 1, in Fe, 1 by 3 3, in Fe3O4, 3 to equalize Fe, we take 3 atoms of Fe on the LHS. 3 Fe4H2O Fe3O4 4H2, 1.8, Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. 3 Fe4H2O Fe3O4 4H2, 1.9, balanced equation. The numbers of atoms of elements on both sides of equation, 1.9, are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation, 1.9. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G, L, AQ, and S, respectively. The word aqueous, AQ, is written if the reactant or product is present as a solution in water. The balanced equation 1.9 becomes 3 Fe, S, 4H2O, G, Fe3O4, S, 4H2, G, 1.10. Note that the symbol Vg is used with H2O to indicate that in this reaction water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions, such as temperature, pressure, catalyst, etc., for the reaction are indicated above and or below the arrow in the equation. For example, CO, G, 2H, G, 26CO, AQ, 12HO, L, 22, 1.11, 340 ATM CHOH, L, 3 sunlight chlorophyll CHO, AQ, 60612 glucose, 22, AQ, 6HO, L, 2, 1.12. Using these steps, can you balance equation 1.2 given in the text earlier? Chemical Reactions and Equations 5 2024 to 25 QUESTIONS 1. 2, 3. Why should a magnesium ribbon be cleaned before burning in air? Write the balanced equation for the following chemical reactions. 1. Hydrogen chlorine hydrogen chloride. 2. Barium chloride aluminium sulfate barium sulfate aluminium chloride. 3. Sodium water sodium hydroxide hydrogen. Write a balanced chemical equation with state symbols for the following reactions. 1. Solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. 2. Sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride solution and water. 1.2 Types of chemical reactions TIONS. We have learnt in class 9 that during a chemical reaction atoms of do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapters 3 and 4. 1.2.1 Combination reaction Figure 1.3 Formation of slaked lime by the reaction of calcium oxide with water Activity 1.4 Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in Figure 1.3. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. CHOWS, quick lime, H2O, L, CaOH2, AQ, heat, slaked lime, 1.13. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. The solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Calcium CaOH2, AQ, CO2, G, CaCO3, S, calcium hydroxide, burning of coal carbonate, H2O, L. Let us discuss some more examples of combination reactions. 1. CSO2, G, CO2, G, 2. Formation of water from H2, G, and O2, G, 2H2, G, O2, G, 2H2O, L, 1.16. In simple language we can say that when two or more substances, elements or compounds, combine to form a single product, the reactions are called combination reactions. In Activity 1.4, we also observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. Other examples of exothermic reactions are I. Burning of natural gas CH4, G, 2O2, G, CO2, G, 2H2O, G, 2. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is respiration, the process of which you will study in Chapter 6. C6H12O6 AQ, 6O2 AQ, 6CO2 AQ, 6H2O L, energy, glucose. 3. The decomposition of vegetable matter into compost is also an example of an exothermic reaction. Identify the type of the reaction taking place in Activity 1.1, where heat is given out along with the formation of a single product. 1.14, 1.15, 1.17, 1.18, Chemical Reactions and Equations 7 2024 to 25 1.2.2 Decomposition Reaction Figure 1.4 Correct way of heating the boiling tube containing crystals of ferrous sulfate and of smelling the odor. Activity 1.5 N. Take about 2 g ferrous sulfate crystals in a dry boiling tube. N. Note the color of the ferrous sulfate crystals. N. Heat the boiling tube over the flame of a burner or spirit lamp as shown in Figure 1.4. N. Observe the color of the crystals after heating. Have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. 2 FeSO4 S. Heat ferrous sulfate Fe2O3 S. SO2 G. SO3 G. Ferric oxide 1.19. In this reaction you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals FeSO4 7H2O lose water when heated and the color of the crystals changes. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Ferric oxide is a solid, while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. CaCO3 S. Limestone, heat CaCO2 G. Quicklime 1.20. Another example of a thermal decomposition reaction is given in Activity 1.6. Activity 1.6 Figure 1.5 Heating of lead nitrate and emission of nitrogen dioxide 88N. Take about 2 g lead nitrate powder in a boiling tube. N. Hold the boiling tube with a pair of tongs and heat it over a flame, as shown in Figure 1.5. N. What do you observe? Note down the change, if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, NO2. NO3, 2, S. Heat, lead nitrate, 2 PbO, S. Lead oxide, 4 NO2, G, O2, G, nitrogen, oxygen, dioxide, 1.21. Let us perform some more decomposition reactions as given in Activities 1.7 and 1.8. Activity 1.7 N. Take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in Figure 1.6. N. Connect these electrodes to a 6-volt battery. N. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulphuric acid to the water. N. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. N. Switch on the current and leave the apparatus undisturbed for some time. And you will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. N. Is the volume of the gas collected the same in both the test tubes? N. Once the test tubes are filled with the respective gases, remove them carefully. N. Test these gases one by one by bringing a burning candle close to the mouth of the test tubes. Caution: this step must be performed carefully by the teacher. N. What happens in each case? N. Which gas is present in each test tube? Activity 1.8. N. Take about 2 g silver chloride in a china dish. N. What is its color? N. Place this china dish in sunlight for some time, figure 1.7. N. Observe the color of the silver chloride after some time. Figure 1.6. Electrolysis of water. Figure 1.7. You will see that white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. 2AgCl, S, sunlight 2Ag, S, Cl2, G, 1.22. Silver chloride turns gray in sunlight to form silver metal. Chemical reactions and equations 999 2024 to 25. Silver bromide also behaves in the same way. 2AgBr, S, sunlight 2Ag, S, Br2, G, 1.23. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Carry out the following activity. Take about 2 g barium hydroxide in a test tube. Add 1 g of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or endothermic reaction? Questions 1. 2. A solution of a substance X is used for whitewashing. 1. Name the substance X and write its formula. 2. Write the reaction of the substance X named in I above with water. Why is the amount of gas collected in one of the test tubes in activity 1.7 double of the amount collected in the other? Name this gas. 1.2.3 Displacement reaction activity 1.9 Figure 1.8 A. Iron nails dipped in copper sulfate solution. N. Take 3 iron nails and clean them by rubbing with sandpaper. Tubes marked as A and B. In each test tube, take about 10 milliliters copper sulfate solution. N. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Figure 1.8 A. Keep 1 iron nail aside for comparison. N. After 20 minutes, take out the iron nails from the copper sulfate solution. N. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B, figure 1.8 B. N. Also, compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside, figure 1.8 B. 8b. Iron nails and copper sulfate solutions compared before and after the experiment. Why does the iron nail become brownish in color and the blue color of copper sulfate solution fades? The following chemical reaction takes place in this activity phase: CuSO4, Aq, copper sulfate, FeSO4, Aq, Cus, iron sulfate, 1.24. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are ZnSCuSO4, Aq, copper sulfate, PbSCuCl2, Aq, copper chloride, ZnSO4, Aq, Cus, zinc sulfate, PbCl2, Aq, Cus, lead chloride, 1.25, 1.26. Zinc and lead are more reactive elements than copper. They displace copper from its compounds. 1.2.4 Double displacement reaction activity 1.10 Take about 3 milliliters of sodium sulfate solution in a test tube. In another test tube, take about 3 milliliters of barium chloride solution. Mix the two solutions, figure 1.9. What do you observe? You will observe that a white substance, which is insoluble in water, is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Na2SO4, Aq, BaCl2, Aq, BaSO4, S, 2NaCl, Aq, sodium sulfate, barium chloride, barium, sodium sulfate, chloride, 1.27. Figure 1.9 Formation of barium sulfate and sodium chloride chemical reactions and equations 11, 20, 24 to 25. So what causes this? The white precipitate of BaSO4 is formed by the reaction of 2,4 and Ba2. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Recall activity 1.2, where you have mixed the solutions of lead, 2, nitrate and potassium iodide. 1. What was the color of the precipitate formed? Can you name the compound precipitated? 2. Write the balanced chemical equation for this reaction. 3. Is this also a double displacement reaction? 1.2.5 Oxidation and reduction figure 1.10 Oxidation of copper to copper oxide activity 1.112 CuO2 Heat a china dish containing about 1 g copper powder. Figure 1.10. What do you observe? The surface of copper powder becomes coated with black copper, oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. 2CuO, 1.28. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. CuOH heat 2CuHO2, 1.29. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction, 1.29, the copper, oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized. gets reduced during a reaction. Such reactions are called oxidation-reduction reactions or redox reactions. Some other examples of redox reactions are ZNOC-ZnCO4 MnOHCl MnCl HOCl 22222 1.30 1.31 1.32 Action 1.31 Carbon is oxidized to CO and ZNO is reduced to Zn. In reaction 1.32 HCl is oxidized to Cl2 whereas MnO2 is reduced to MnCl2. From the above examples we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Recall activity 1.1, where a magnesium ribbon burns with a dazzling flame in air, oxygen, and changes into a white substance, magnesium oxide. Is magnesium being oxidized or reduced in this reaction? 1.3 Haha, have you observed the effects of oxide-REA reactions in everyday AAE life? 1.3.1 Corrosion oxidation tion Why life? Why life? You must have observed that iron articles are shiny when new, but get coated with a reddish-brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year an enormous amount of money is spent to replace damaged iron. You will learn more about corrosion in Chapter 3. 1.3.2 Rancidity. Have you ever tasted or smelt the fat/oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually substances which prevent oxidation, antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down oxidation. Do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized? QUESTIONS 1. 2, 3. Why does the color of copper sulfate solution change when an iron nail is dipped in it? Give an example of a double displacement reaction other than the one given in Activity 1.10. Identify the substances that are oxidized and the substances that are reduced in the following reactions. 1. 4 Na, SO2, G, 2 Na 2OS, 2, CuOSH2, G, cos H2O, L. Chemical reactions and equations 13 20-24-25. What you have learned. A complete chemical equation represents the reactants, products, and their physical states symbolically. A chemical equation is balanced so that the numbers of atoms of each type involved in a chemical reaction are the same on the reactant and product sides of the equation. Equations must always be balanced. In a combination reaction, two or more substances combine to form a new single substance. Decomposition reactions are opposite to combination reactions. Action. A single substance decomposes to give two or more substances. Reactions in which heat is given out along with the products are called exothermic reactions. Reactions in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or groups of atoms, ions, are exchanged in double displacement reactions. Precipitation reactions produce insoluble salts. Reactions also involve the gain or loss of oxygen or hydrogen by substances. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. Exercises 1. Which of the statements about the reaction below are incorrect? 2PbO, S CS2Pb, S CO2G, A, lead is getting reduced. B, C, D, carbon dioxide is getting oxidized. Carbon is getting oxidized. Lead oxide is getting reduced. 1, A and B, 2, 3, 4, A and C, A, B, and C, all 2. Fe 2032 al 2032 Fe. The above reaction is an example of A, combination reaction. B, double displacement reaction. D, decomposition reaction. Displacement reaction. 3. What happens when dilute hydrochloric acid is added to iron fillings? Tick the correct answer. A. Hydrogen gas and iron chloride are produced. B, C, D. Chlorine gas and iron hydroxide are produced. No reaction takes place. Iron salt and water are produced. 4. What is a balanced chemical equation? Why should chemical equations be balanced? 5. Translate the following statements into chemical equations and then balance them. A. Hydrogen gas combines with nitrogen to form ammonia. B, C, D. Hydrogen sulfide gas burns in air to give water and sulfur dioxide. Barium chloride reacts with aluminium sulfate to give aluminium chloride and a precipitate of barium sulfate. Potassium metal reacts with water to give potassium hydroxide and hydrogen gas. 6. Balance the following chemical equations. A. HNO3CaOH2Ca, NO3, 2H2O, B, C, D, B, C, D, B, C, D. NaOH H2SO4 not 2 SO4 H2O NaClAgNO3 AgClNaNO3 BaCl2 H2SO4 BaSO4 HCl7. Write the balanced chemical equations for the following reactions. A. Calcium hydroxide, carbon dioxide, calcium carbonate, water, zinc, silver nitrate, zinc nitrate, silver, aluminium, copper chloride, aluminium chloride. Take 4 beakers and...
Thanks. Please like, share, subscribe.